Very good morning to you, and welcome to Renewable Watch's webinar on predictive maintenance of wind turbines, improving asset performance and profitability. My name is Alok Brara. I'm publisher of Renewable Watch magazine, and along with my colleague Khushbu Goel, who is effectively the editor of the magazine, I'll be moderating the conference along with her. The agenda today is we are going to have a short presentation to begin with by Onyx, and then we are going to have a panel discussion. The presentation is going to be made by Sharath Prabhakaran, who's a business development manager, and Henry Tanner, who's product manager, advanced sensing at Onyx Insight. And the panel discussion will have Kapil Kasotia, Chief Operating Officer of AMP Energy India, Atul Pachauri, who is Head of Operations and Maintenance for O2 Power, Rajiv Babaji Samant, who's Consultant in Business Development with Tata Power, also Neeraj Shah, who is Vice President O&M at Parva Energy, and of course, Henry will be joining the discussion as well. So the presentation will come after a few minutes. I'm going to introduce first the two presenters, and I'm going to present the panelists after the presentation. And so let me just do the introductions first. And Sharath Prabhakaran, I should say, is Business Development Manager, India, Onyx Insight, has got almost 2 decades of experience in design, testing, and certification of wind turbine mechanical systems. Is passionate about wind energy, and over the course of his career has focused on improving the reliability of wind turbines and thus reducing the cost of energy. In his current role, he focuses on helping wind operators in India to reduce the cost of energy by aiding transition to digitalization of operations. He's a mechanical engineer by training. Welcome, Mr. Prabhakaran. Also with us is Henry Tanner, who is product manager of advanced sensing at Onyx Insight. And he has worked a great deal with rotating machinery and has expertise in gearbox design, and also done a lot of simulation work in wind, also in automotive and aerospace as well. Before he joined Onyx, he was principal engineer for R&D at Romax Technology Limited, also a business development manager earlier on at Hexagon AB as well. So welcome, Mr. Tanner. And as I said, we're going to begin the presentation by Onyx first. And do they have the presentation rights, Khushbu or Iqbal?
Yes, they do.
Yeah. Okay, wonderful. Okay, and so it's over to the Onyx team. I don't know whether it's Mr. Prabhakaran or Mr. Tanner who will join us. But before you do that, let me mention to the delegates, please put on the questions that you have. You don't have to wait for the presentation to end. The questions can be put in Q&A and not so much in chat, please. That would just help us get your answers in a better way. Over to you. Over to Onyx.
Great. Thanks, hello. Thank you so much. Let me share my screen first. Right. Is my screen? Yeah. Can you see my screen?
It needs to be, yes, you need to put it in slideshow, I think.
Yeah, it's on slideshow.
Okay, we are seeing both the slide 1 and slide 2. So.
Or do I leave this on the presentation mode, on the PowerPoint mode?
I think this is better than what we had before. Yeah.
This is better. Yeah. Okay. So let's do this. Let's do this. Great. Thanks a lot. Thanks for your introductions. It's great to be here speaking to the platform, and a very good morning to all the listeners and also our esteemed guests in the panel. Thanks to Renewable Watch for putting this together. And yeah, it's great to be here talking to you today. So before I hand over to Henry, my colleague Henry, to talk about our core technical offering, I will do a quick run through of a few slides and introduce Onyx to you and what we bring to the how we support the wind industry globally to make operations more efficient. So yeah, Onyx, we are a trusted and unbiased provider of predictive analytics for wind industry. We are a part of British Petroleum with headquarters in UK and office in other 6 locations across the globe. We have a long heritage of actual machinery, rotating machinery design and development and testing. And we have leveraged this experience with wind turbine development into developing CMS solutions, condition monitoring solutions for the industry. As of today, we are monitoring more than 9,500 turbines globally for our key customers across the globe, and also having installed our proprietary hardware sensor systems on more than 7,000 wind turbines globally. We have a huge database of on wind turbine reliability, having delivered several due diligence projects across the globe, and also keen expertise in inspection services and gearbox teardowns and so on, actual on the field services for the wind market. So we have three main verticals and our three main offerings to our business. First and foremost is the software and analytics services, where we have developed platform software and analytic platform called like Fleet Monitor, AHub, and Field Pro, which are analytics and data management platforms for wind turbine predictive maintenance. We not only use this software for to enable our customers to make the transition into predictive analytics, but we also use this software to deliver monitoring services to our clients. And enabling the analytics is our advanced sensing hardware products. EcoCMS is the product for drivetrain condition monitoring and sensor research, and launched late last year for condition monitoring of pitch bearings, for detection of pitch bearings. And we've also developed solutions to integrate continuous monitoring of oil quality into the vibration data as well, to complement the direct vibration data as well. And of course, the backbone of all of this is our engineering expertise. We are all wind turbine engineers, climbing wind turbines and solving real world problems for our customers. So moving on, EcoCMS, as I said, is our advanced sensing solution for vibration and vibration-based condition monitoring. This is an 8-channel system, completely digital system, which collects triaxial vibration from each sensor and temperature to enable effective vibration-based condition monitoring of the machinery. It measures shaft speed, and also option to integrate lubricant gearbox oil data into the data stream that's being monitored, and multiple options for connectivity as well. I introduced EcoPitch already. It's a novel technology that we rolled out late last year for health monitoring of pitch bearings. This is a combination of accelerometers and displacement sensors with the multiple options for connectivity as well. Moving on to the software side, the analytics platform side. So Onyx AI Hub is one platform for empowered, scalable fleet management. This is the overarching platform which brings multiple data streams together, SCADA data, vibration data, oil analytics, and so on, and all the other third-party data that is generated in operations, and they're bringing the stakeholders, the management team, the engineering team, and the site team to enable them to look at this data in one platform and together and make quick and effective decisions. So summarizing, so what we aim to achieve with AI Hub is efficient data management, efficient and early fault detection, and efficient collaboration between the stakeholders for faster and more effective resolution. Moving on, Fleet Monitor is our vibration-based analytics platform and also our most popular product. This sits one level below AI Hub, and this is designed and developed for wind farm vibration-based condition monitoring. And this platform is with which we deliver more than 9,500 monitoring services across the globe. This is a hardware-independent cloud-hosted platform, which means that we can read in data from third-party sensor systems to enable predictive analytics. We are delivering a lot of this work across the globe, using third-party sensor systems to bring in data and run the analytics and help our customers with the transition to predictive analytics. So that's a quick introduction of Onyx and what we deliver to wind turbine operators across the globe. That's also the end of my presentation. I would like to hand over to Henry at this point to take over and talk more in detail about our technical offering. Over to you, Henry.
Hi everyone. Can you hear me okay?
Yeah, we can hear you fine.
Okay, good. I'll try and share my screen. Thanks for the introduction, Sharath. Okay. So,
Works. Perfect.
Can you see that? Yeah. Hi everyone. Real pleasure to be here today. It's my first webinar I've done in India, which is really nice. Although it was quite an early start for me, so forgive me if I'm a little bit slow and sleepy. It was a pretty early wake up today, but very happy to be here and be talking to you, and looking forward to the panel discussion and the questions that might be coming in. So please please ask as much as you can on the Q&A. So I'm Henry Tanner. I'm the product manager for advanced sensing at Onyx. So I'm responsible for all the hardware products, present and future. And today I'll be talking to you about full turbine predictive maintenance. So branching out of the just drivetrain predictive maintenance and looking at the full turbine. And I'll be giving a bit more of a technical overview of what's going on in the industry, what's going on at Onyx, some of the new things out there that are sort of on the more cutting edge of predictive maintenance. And I think I've got 25 minutes. So I'll try and stick to that. Is that about right?
Actually, yes, a bit less than that.
A bit less than that. Okay. I will motor through.
Yes.
Okay. So yeah, from checking my watch, it's to try and keep time. So the agenda, I'll give you a quick introduction to Onyx, just adding a bit to what Sharath said, and then I'll jump straight in with the advances in predictive maintenance. So I've chosen 4 advances that we're doing at Onyx. One is online pitch bearing monitoring. The second is blade health management. That's a very, very hot topic. It's becoming very, very expensive for operators and owners to manage the health of their blades. Tower and foundation monitoring, and also rotor imbalance monitoring. If we have time, I may leave off the rotor imbalance if we're running a bit behind schedule. So what does Onyx do? As Sharath said, we've got 3 core elements to the business. We've got advanced sensing, so we actually make our own condition monitoring hardware that we manufacture in England, ship all over the world, install on wind turbines. We've got our drivetrain condition monitoring system, EcoCMS. We've also got EcoPitch, our pitch bearing monitoring system. The next part of our business is software and analytics. So this is where we can take data from our own hardware, but also integrate third-party vibration data from other vendors, and pretty much all kinds of data that belongs to a wind turbine or a wind farm, we can now integrate into our software and analytics platforms. I won't go into too much detail there. And finally, it's all underpinned by our global engineering and consulting team. So not only have we got the hardware and the software, we've also got engineers pretty much everywhere on the globe that can come out and support operators and owners with their particular problems, from root cause analysis to condition monitoring systems, that sort of thing. Also, in terms of asset lifecycle solutions, we've got a range of strategies. So this is kind of it was just we just did drivetrain analytics, but now we're looking at whole wind turbine analytics. So yeah, and I'll discuss that more in this presentation. We're looking at towers and foundations now. looking at lost energy and reliability analytics, so really sort of squeezing out the last 2 or 3% from your wind farm and your assets. We do maintenance and operational expenditure forecasting and consulting. Root cause analysis. So if you're being plagued by particular failures at your site, we can do root cause analysis and try and get to the bottom of problems and maybe help you get rid of them. And more recently, blade health management, which I'll discuss in a bit more detail. We also have different solutions for different stages of the wind farm life cycle, from end of warranty to lifetime extension. There's a big list there. I won't go into all those today. So predictive maintenance beyond the drivetrain. So Onyx started about 15 years ago, and we were exclusively focused on the gearbox, the main bearings and the generator bearings. And then we released our flagship hardware product to capture all the vibration data from those components. It was very, very successful. We now monitor over 10,000 wind turbines. We have over 7,000 Eco CMS units installed. It works very well. It's extremely reliable. It gives you a high, a long lead time for many of these failures. It's very effective. So we were sort of thinking, what's next? What's next for Onyx? And obviously, we've got the rest of the wind turbine that has components that are failing. So the pitch bearing systems, they have a high failure rate and are very, very expensive. We weren't monitoring this, so we released a new product called Eco Pitch, specifically for pitch bearings. I'll discuss that in a bit more detail next. Blade health is becoming a real issue for aging wind farms. Lots of blade problems, and that can severely impact the power generation capacity of your wind turbine generator. We've got rotor imbalance. There's a variety of reasons for that. Again, that can cause major component health issues and also lead to lost energy. Not a good thing. So we're extending to that area. Oil sensing, we've been progressively increasing our oil sensing capability for the last 4 or 5 years. I won't talk about that in this presentation, but we've done a lot of work on oil now. Tower and foundation. So this is a very interesting topic, really. And as we see, basically, as wind turbines age, their towers and foundations can lose stiffness and structural integrity, and eventually fall over, lead to catastrophic failure. It's a shame, because if the towers and foundations are good and can be repaired, you can do very effective repower campaigns. So you can basically keep the tower and the foundations and just replace the nacelle or just replace the gearbox. But if you don't know if the tower and foundation is healthy, you can be opening yourself up to a huge amount of risk. So this is a quite an exciting new area that I'll discuss today. So Eco Pitch. I'll just describe really how Eco Pitch works for pitch bearings. So a bit about pitch bearings. Pitch bearings are really subjected to some quite aggressive loads. Normally a bearing is rotating when it's under load, and you can have the lubricant film thickness develop that protects all the surfaces of the bearing. However, with a slewing bearing, with a pitch bearing, it spends most of its time fixed in one position, which means it's very hard to get a layer of lubricant between the contacting surfaces. So you get metal on metal contact. You have huge loads on the pitch bearings because they take all the wind and they're rotating. So you get huge kind of time varying moments on a pitch bearing. And also both the inner and outer raceway are full of bolt holes as well, which can lead to stress concentrations. So there's a lot of pitch bearing failure problems in the field, and this results in very high costs because your blade essentially can fall off, or your hub can crack, well, you need a crane to do the repair as well. The repairs aren't cheap. So just a bit about the failure modes of pitch bearing. Let me just get a pen. Okay, so you can have macro pitting due to subsurface fatigue as a classic failure mode. Surface fatigue on the inner and outer raceway and rollers due to wear debris. The blade bolts can fail. They're also under high loads. You can have the separation of the blade and the bearing, so the actual connections between the blade and the bearing can begin to fail and open up and become loose, and also the actuation system. So the actuation system, either geared or hydraulic, that rotates the blade, can also fail, which can be very expensive. Root causes: undersized or under-engineered bearings. Like I said, the loading is very harsh, and also poorly understood, because well, to understand the sort of stiffness of that bearing is quite challenging, and a lot of design approaches won't fully take account for the amount of deflections that bearing will experience. So as a result, there's usually a chance that bearing itself is undersized. Often when a pitch bearing fails and is replaced, it's replaced with a slightly higher rating. So that's a big issue. You can have ellipse truncation, where the rollers contact the edge of the raceways, which can lead to macro pitting of the rollers, loss of grease, age, and environmental degradation. Consequences are high repair costs, a lot of downtime. It can take a really long time to replace a pitch bearing. You're talking months, which is very expensive, especially if it's in your windy season. So it can be really, really expensive, and you can also lose a blade and potentially have a catastrophic failure of the full wind turbine as well if you lose a blade quite suddenly. And that does happen. And there's no accepted monitoring or detection solution for pitch bearings. It's a total blind spot in the wind turbine. So let's have a look at EcoPitch, which is the product that we brought to market to alleviate this. So it's a permanent hardware solution. It's mounted inside the hub. It monitors the pitch bearings. It monitors the blade to bearing connection. It has flexible communication options, so it can work on 4G, Wi-Fi, or Ethernet. It also monitors the bolts inside the blade as well. If you're not ready for a permanent hardware installation, we also have a temporary install, so we can do one-off campaigns where an Onyx engineer can come out and just test the health of the pitch bearings as a one-off. So we have a permanent install and a temporary version. The kit that it comes with looks like this. You get a lot of stuff in the box. There are quite a lot of sensors in there, which I will explain. I'll explain in a bit more detail what they all do. But yeah, you get a lot of sensing equipment inside the box. So it looks like this. You have a normal Eco CMS unit and the external EcoPitch cabinet as well. So how does it work? What does it come with? Well, first of all, for every single pitch bearing, you have at least one displacement sensor. So this measures the relative displacement between the inner and outer races of the pitch bearings. So this monitors basically the stiffness of the bearing. Your bearing should be quite stiff and shouldn't displace a huge amount during rotation. That's like a healthy bearing. And as the bearing becomes less stiff, the displacements will increase, and you can track this with this sensor. Typically, we just install one displacement sensor, but for certain wind turbine types, we might install 2 displacement sensors. We have an RPM sensor. So this, first of all, measures whether the pitch bearing actuation system is moving or not, which is useful for other reasons. And also it measures how smooth the actuation system is rotating. So you'd expect a nice smooth rotation, but yeah, if it's not smooth, there's probably a problem with your actuation system. So that's how we detect that. That's a close-up shot of the displacement sensor.
Mr. Tanner, 10 more minutes.
Yes, 10.
Yes.
Okay, good. We also have a MEMS accelerometer there, so that is useful for picking up vibration caused by damage inside the bearing. Also a vibrating or noisy actuation system, we can detect the vibrations of that, and all this data can go into Fleet Monitor, our condition monitoring software. This is the portable kit. I'll show you a brief data analysis example. So for a healthy bearing, this is after replacement. What we can do is we can simulate a pitching event, so we can actually make the turbine pitch a full 0 to 90 degrees. So go 90 degrees one way and then 90 degrees another way, and then we can look at the data coming back from the sensors. So displacement sensors, we see a nice smooth displacement reading, and it's also quite a low displacement value. So the bearing's quite stiff and it's displacing quite smoothly during a pitching event. So this is quite good. And also the vibration data is basically nothing. So the bearing isn't vibrating. So this is a healthy bearing after a replacement's happened. So I've got the same data here for an unhealthy bearing. We did a pitching event, the same pitching event again. The displacement readings are, for a start, have a much higher peak, which means the bearing is less stiff and its structural integrity has been compromised. There's also a very noisy displacement signal, which is not good. There's something very loose inside this bearing. And also the vibration data here, there's a high amount of vibration, and you can actually do some further analysis on this in Fleet Monitor and try and diagnose exactly what frequency content in here that there is, and what type of failure that would lead to. Sorry, what root cause would be driving this vibration signature here. Okay, so also blade joint failure. So the actual sometimes when the blade can be connected to the bearing with blade inserts, these can also fail, and you can monitor these with EcoPitch as well. So this is something you can extend EcoPitch to do. Blade health management. I will discuss briefly. So this is a new area. That there are different types of inspections for blade O&M. You can basically climb up onto the blade and take pictures. You can stand on the ground and do telescopic inspections, or you can use drones. Now these are becoming quite popular and quite common. That fly up and take pictures of the blades and try to spot damage. You can also have acoustic-based solutions. So something that a microphone essentially that you stick onto the tower that listens to the blade as it goes round. The problem with these methods are there's not really a recognized solution in the market, and it's very unstructured data, whereas vibration data is quite predictable now. It's just vibration files that you can bring into Fleet Monitor. For monitoring blades, it's a much bigger challenge, and there's a huge amount of different types of data, and it's very hard to extract any value from this data. So we've got this product AI Hub that lets you collect data from a variety of sources, drone data for sure, We can look at the blade model, risk factors, the defect history. There's a full data platform here. You can bring all of your all of your different types of blade monitoring data. We have a prioritization scheme that basically lets you prioritize damages based on how severe it is and when you need to do the repair. And there's also a lot of action support inside AI Hub as well. And we also have blade engineers now that can support you with this data. I will try to move on to Taran foundation monitoring as my last topic. So this is one of my favorite. This is one of my favorite topics.
5 more minutes.
5 minutes, no problem. So yeah, one of my favorite topics to talk about is Taran foundation monitoring, which I'll try and do in 5 minutes. So this is becoming a big issue in the industry as wind turbines age. A wind turbine foundation is a unique concrete structure, and they're all very, very different. There's a big lack of design consensus in how you should make a concrete foundation. Wind turbines are getting bigger, as you know, but the foundations are not getting bigger as fast as the wind turbines are getting bigger. So we see, bigger wind turbines with very similar foundations, which can lead to higher stresses. Foundation remediation or repair is very, very expensive. Foundation stiffness monitoring is very time consuming and very, very challenging. So to actually determine the health of your wind turbine foundation is quite hard. So yeah, the catastrophic failure is expensive. Repairing is expensive. However, if you can detect issues early, you can save a huge amount of money. Basically, by doing a small early repair is very, very cheap than obviously waiting for huge cracks to develop, and obviously the whole thing falling over is very, very expensive as well because your whole wind turbine is destroyed. You can also do risk management. So if you want to repower an aging asset, if you know the health of your foundation, you can alleviate risk. You can validate your foundations as well. You can protect against extreme weather events, and also if you're transferring the ownership, if you can prove to your buyer that your foundations are all sound, then that's very, very good. You can sell your wind farm at a higher price. So I'll just explain how it works. Basically, every wind turbine has a natural frequency, and this natural frequency is based on the stiffness of the full system and the foundation combined. So the stiffness of the tower and the stiffness of the foundation, the stiffness of the soil around it, and this is a very, very particular frequency between 0.2 and 1 hertz. So because of our MEMS-based accelerometers, we can very accurately determine this vibration signal. And what's important is we can detect when this signal changes. So if this frequency changes, usually it gets lower as the structure gets less stiff. We can then set an alarm and determine when the tower needs some repair work. So what causes changes in stiffness can be loose bolts or joints, tower weakening or cracking, foundation stiffness, if there's cracks in the foundation, or if there's changes in the soil surrounding the foundation concrete. So we can monitor this now. We can bring it into Fleet Monitor, and operators and owners can start using this data. So yeah, it works with EcoCMS and our MEMS accelerometers. It's a really great service, and hopefully some of you find that interesting. I will leave rotor and balance for another day because it appears we've run out of time, but I look forward to some questions later.
You can have 90 more seconds.
90 seconds, okay. What I'll actually show you then is just I'll finish off I'll finish off tower monitoring because this is quite an interesting graph. So here I've got a case study that we did where we looked at a full fleet of wind turbines. So here we've got a baseline wind turbine that we've taken the natural frequency of using Eco CMS, and for the healthy fleet, most of the wind turbines will oscillate at 0.276 hertz. And quite consistently we'll track at this thing. So that's basically telling you the stiffness of a healthy wind turbine in your fleet. And then we found two that were had compromised stiffness. So these are basically oscillating at a lower frequency. We picked these up for the wind turbine owners and operators, and this allowed them to do quite a cheap repair. So they just had to tighten the anchors in a few places and bring the stiffness back up to the baseline. So both of them, after remediation, went straight back up to a healthy level. And this is great because if they'd left this run, turbine A and turbine B, for another 6 months or a year or 2 years, it would have been a very, very expensive repair and perhaps a catastrophic failure. So this is a way that monitoring can really add a lot of value to an operator. So I'll leave it there, and we will do rotor and balance another day.
Okay. Thank you very much. Thanks, Henry, as well as Sharath. We're ready to begin the panel discussion, and let me introduce the panelists to you. Just want to mention that this is in alphabetic order, right? Khushbu, you can hear me, right? Just to be sure.
Yes, Alok. Yes.
Okay. Yeah. We have with us Mr. Kapil Kasotia, who is Chief Operating Officer for Utility, Wind, Hybrid Storage, and Strategic Initiatives at AMP Energy or AMP Energy. He has about 2 decades of experience. He's delivered almost 4 gigawatt of greenfield development in wind, solar, and hybrid projects. Of the 2 decades of experience, he's got a decade and a half has been in the renewable sector, working in business development, project development, financial analysis, also has dealt with procurement, regulatory, transmission, and other technical issues. At AMP, as I mentioned, he's working on wind, hybrid, storage, also other strategic initiatives. And before that, he has worked with the Sembcorp Green Infra, also with Veena Energy. And he's an alumnus of IIM Calcutta. Welcome, Mr. Kasotia. Wonderful to have you with us. And are we able to hear you? If you can just say hello, that'll be.
Thank you.
Okay, great. Yes. Also, that's Atul Pachauri. He's head of operations and maintenance at O2 Power. Has about a decade and a half experience in renewable energy. Core areas of expert are asset management, O&M, SCADA, SAP, manpower planning, power plant controlling. He is currently responsible for operations into renewable energy plants and technical feasibility of mergers and acquisitions. And before that, he's worked with Sterling and Wilson, with Fortum, and with Blanco and Mrs. Long. And he is electrical and electronics engineer from College of Engineering, Roorkee. Also is a chartered engineer and is a fellow member of IETE. Great to have you with us, Mr. Pachauri. Wonderful to have you with us. Also with us is Mr. Sharath, we've already introduced him, Mr. Rajiv Samant, who is consultant, Wind Power Business Development, Tata Power. He has 3.5 decades of experience, a great deal lately or last many years in wind, O&M, and power utilities, but in his earlier part of his life also with paints and pharmaceuticals and other companies as well. He has done a lot of work in R&D, in technical services, in production, corporate planning and strategy, business development, and of course O&M of wind assets as well. He has served as director and chairman on 9 subsidiary companies of Tata Power Company. Also as vice president of India Wind Power Association. He's a chemical engineer by training. Really wonderful to have you with us, Mr. Samant. We're very grateful you could join us today, sir. Finally, we have with us Mr. Neeraj Shah, who is Vice President, Wind O&M at Apraava. Has almost got 2.5 decades of experience in the power sector. Currently is responsible for, as I said, leading operations and maintenance at Apraava Energy. He is earlier worked for 2 decades on gas turbines at CLP. Apraava Energy, I think, is a new name for or is part of CLP. He has led engineering activities at CLP for solar, wind, and transmission engineering, and has a lot of interest in automation and digitalization. So today's topic is of particular interest to him. He's an electrical engineer by training from MS University of Vadodara. And Mr. Tanner is also going to be on this one. I've already introduced him. So these are the panelists. The questions that I'm going to ask the panelists today are going to be, what are the current strategies for risk management for O&M of wind turbines? What are the key challenges they are encountering? And how will moving to predictive maintenance help them? What's the role advanced analytics and digital technologies like machine learning and artificial intelligence can play? What are the long-term cost benefits of using predictive maintenance techniques, and what is the way forward for O&M of wind turbines? So I'm going to maybe merge a few questions here and there. We'll make this fairly interactive. I'll make sure that everyone has a first shot at answering a question, therefore that's what we'll do. But before I go there, I'm just going to ask panelists: do you have any questions for Mr. Tanner or Mr. Prabhakaran, or do you have any disagreements with them also? Okay. Mr. Kasoria? No. Okay. Mr. Pachauri?
Yes. So not on the disagreement, but Mr. Tanner, you have means really wonderful things what you are doing at Onyx. But kindly make sure that these things are either incorporated with the OEM efforts or either available at a very cheaper cost. Because in today's scenario, if we are building huge cost, which we have seen in all SaaS-based models, so if we will build them on, then definitely the IRRs and other things will not be going to allow us to move further for these types of solutions.
Maybe Sharath can answer that as well. Sharath, you want to answer that? Or is that Henry?
I'll give it a go. Yeah. So I mean, it's what it comes down to, the price is how much are those issues costing you as an owner operator, and if you're seeing very expensive issues with tower or rotor imbalance or the gearbox, you know how much that's costing you per year, and the solution that we offer has to be cost effective, so it has to be a lot less than what you're paying already for repairs. So hopefully our solutions are cost effective in India. If they're not, you can take it up with my colleague Sharath. but yeah, we always try to have a very clear cost benefit analysis put in front of you, and that's why our solutions are so successful, because they save people a lot of money basically. Otherwise, we wouldn't be selling these in our thousands. But it is a good point. At the end of the day, you have an operational budget and you've got to spend that somewhere.
Because in Indian context, almost 90% of the wind turbine generators installed in India are being operated by OEMs only, right? So it is really very much necessary to bring OEMs also on the common platform. Because we individually as the IPP, let's say if I am the owner of the turbine, so I cannot convince them upfront that I'll install some of the sensors and then will blame you that the pitch bearing and other things are not working properly. So it is tough.
Okay. Mr. Samant?
Yeah. What I feel is key when we are now, see, as we said now, this all the projects are now on bidding process where the tariffs are going low. The challenge for the operator or the IPP is how to have the least cost for the turbine. And so what is happening is when we are asking the turbine manufacturers to supply the turbine, we are not aware whether the turbine is coming with minimum adequate design, which will take care of all the issues what have been raised by Onyx. So I think if Onyx can come out with a sort of a guide or sort of a table where it is not only wind speed survival is so much, the power curve is so much. Can it come when we order a turbine, this should be a minimum requirement of the turbine design which we should order. So that when we are doing the project itself, during the bidding, we'll be knowing these condition monitoring tools are available and we are having a design which is optimized.
Okay.
Instead of having all these gadgets which we want to buy under OPEX afterwards, because there is no budget provided for the OPEX sort of thing. I like the product which Onyx has offered but we will be all be very helpful with all the IPPs. If this product is, that is what Atul also said, if they're already having this, like if you have a analogy with any car, we say that for a car design, the airbag should be there, so that if any product is designed without airbags, it is not certified. So if it can come in RLM list, this designs, this wind turbine should come with this minimum adequate products like your tower and all those things. It will be very helpful for all of us.
Thank you, sir. Thank you. Thank you. Mr. Shah, any question you have or comment before we get into the discussion?
No, honestly, I don't have any questions. I think they are doing a great job. Whether the price is affordable to me or not is actually my problem, to be very honest. Okay. And I fully, I think the conflict normally I see is that most of the, and Mr. Pachori would agree with me, is that most of these good renewable companies are headed by MBAs who are good at the numbers. And the people who are justifying the failures are the engineers who are on the ground who do not have the money. Am I right, Atul?
Right, sir, right.
So I think what, Henry, we would just like, experts like you is to pitch it in a way. What you are saying, I and Atul and Rajiv, we all agree the kind of losses that we suffer. But the problem is that, the forward-looking losses, it's like just, whether I should buy a life insurance of how much money, because I am not going to enjoy the insurance. It is for my family. So similarly, engineers actually think that, my plant should run in the best way. And we always endeavor to do that. But there are 2 or 3 issues possibly which I don't know whether you have tackled in your product line or not. One of the major problems which I believe is, as an operator, I have 3 or 4 different systems to make my decision. That makes it extremely vulnerable. Because one, my operating of the WTGs is controlled by the SCADA of the OEM. Another, I have AI/ML system which takes data, limited data from that SCADA, makes some interpretation and gives it back to my operator. And the third is a condition monitoring system, which will again be independent. So, somehow we have to, as an industry, learn to collaborate, because this is when we want to actually scale up to this level, this individual expertise is going to ruin the life of the operator. And when the operator gets puzzled, they shy away from seeing what can be seen. And then people would say, okay, everything is managed comprehensively by the OEM. Why the hell should I worry? That's the dimension that I would just like to put forward.
Great.
Yeah, please.
Okay. Okay. Any comments or shall we start with the discussion?
Yeah, we can, Alokji. I was the last one, I think.
No, we need to do that. So let's basically start with the discussion. I'm going to change the order a little bit. I want to get to the challenges first, for sure. What are the big challenges that you are facing in O&M? And let's just begin with the challenges, and then we'll figure out a couple of the things. Let me just start. Mr. Kasodia, we begin with you, sir. What are your biggest headaches, biggest challenges?
I mean, when it comes to the wind turbine, everything is challenging and everything is a headache.
Okay, yes. Okay, okay, let's just say 3 biggest ones.
So, looking at this wind turbine performance for the last decade or so, like various farms and different machines, different OEMs and everything, it's so challenging to get the energy that you predict from these turbines. So it's seldom that you hit a P75 number. It's very rare. And whereas we see in the West, and we hear, the turbines are doing somewhere between P60, P65s as well. And here, despite having long series of data and everything, the turbines just don't perform. And why they don't perform is a black box. And the one point that we always hear in terms of why they are not performing is always the wind. And as we know that for the last 10 years or so, surface winds are decreasing all over the world, up to 10 to 20 meters. And that phenomenon, and then you have like this weather events, El Ninos and others. And year after year, wind speeds are recorded lower. There's a question mark on the wind speeds as well, that what is being recorded by, whether they are accurate or not, and then why the turbines are not performing becomes a bit of a mystery. And then comes unscheduled, breakdowns all the time in these turbines for a variety of reasons, which again, they happen, but we don't know why they happen, like for sure. And I was listening to Henry, and when he was saying, how things can be predicted in O&M. And one thing I noticed, and which I have noticed like previously as well, that to predict anything, everything needs a sensor for each and every instrument. Whether it's a tower, blade, pitch, install a sensor everywhere and monitor it, and whether it's going to fail or not. And I really wonder that, and the comment that why don't they come up with everything? I think they do come up with everything, but we don't have access to all that data. The OEMs have all the data, and they are monitoring each and every parameters. Hundreds and thousands of parameters can be extracted from each. In fact, the intermediate calculations can also be, pulled out to see that what's happening, but we don't have access to it. And under the contract, these guys are doing O&M, and we realize that they are doing it properly. Now, and that, it becomes complicated. Why should I install so many sensors and do what with the data? End of the day, the contract provides that it has to be a consent with the OEMs to do anything. So predictive maintenance, time to fail, and other things, the value of it, working with the OEMs, and the OEMs already having a data to monitor it versus my ability to tell them that what is right or wrong. It's a bit of a complicated.
Okay, Mr. Pachori.
Yes. So biggest issue, as Mr. Kapil have already highlighted few. First of all, we are having the trend of the wind as lesser in the last 1 decade. So first of all, we don't have wind. So second issue arises when we have wind, we are in the breakdowns. Okay. So when the turbine will be in the breakdown, when the wind is there already, then it is a major issue, right? So tackling the OEM in such a way that the guarantees and warranties should go beyond only machine availability. Okay. So currently in any contract, we do not find mean time to repair or mean time between failure as the major KPIs. Only KPIs are available as the plant availability or the wind turbine availability. So, right. So it is 97% available. When wind is not there, it is available fully. But if wind is there, then it is under breakdown. It is already neutralized when the wind was not there. Ultimately, we are losing generation.
Okay. Before I go to Mr. Samant, Sharad, there are a number of questions for you in the Q&A. You may want to answer them, huh?
Sure. Yeah.
Sharad or Henry, whoever wants to answer. Yeah, Mr. Samant.
What has happened is
big challenges. Yeah, the two biggest challenges, let's say. Yeah.
The biggest challenge is this bidding which has come into the picture.
Right.
Due to bidding, the tariffs have gone too low, and whatever the O&M
let me rephrase. The biggest challenges for O&M.
Biggest challenge for O&M are we don't have the OPEX budget itself to buy anything.
Okay.
So if you come with any new gadget, it looks very attractive for all IPPs to buy it, and we know that it is going to perform, but we just don't have any budget for it. I feel if Onyx is able to come with sort of a model called leasing model, where they say that we lease this equipment to you, and they can demonstrate these are the additional units which are able to come extract from it and get the revenue sharing model. That may be the way this Onyx, whatever gadgets they are coming, may be viable in the industry. But the other way around is they insist with the RLM itself or with the OEMs. These are mandatory equipments which need to be there with the turbine. From the start, they are sold as a product in the country.
Okay, we'll come to that one separately as well. Mr. Shah, the big challenges.
So apart from what has been covered by Atul and Kapil, resource is one part, but that is anyway beyond our control. So I think what is controllable at per se is number one challenge is the quality of manpower that we get from the OEM. There is so much of rotation because there is so much of expansion happening on the renewable side. Getting a quality resource as a contractor is a real problem. And possibly Atul and Kapil would second my thoughts that this lack of quality, they can interpret so much of data, but because the people are not experienced enough, we actually have human error induced issues as well. And the second biggest problem which I see is the lack of transparency or the opaqueness that we have from all the WTG owners, the OEMs. And let me just put this in perspective, Alokji, is that when I buy a gas turbine, so the capital project cost of my plant, which I'm ahead of in the gas turbine section, is 2,400 crores. And those guys give me the DCS software with administration password. I can change it. Okay. And here I'm buying a turbine which is just less than 10 crore, and bloody I don't have access to the software. Forget about the access to the software. I don't have even the operating access to switch on the turbines or switch off the turbines. So this kind of situation that we are in, that we pay the money and our complete fate is sealed by the OEMs. This is something which has to shift away, because there are many solutions possible which are available. For example, Onyx, I don't need a separate system. I can bloody well integrate into the existing automation PLC itself. Why should I need a separate system for that? So principally, these flexibilities which are available in the thermal assets, which are priced at more than 200 times of these assets, we are still struggling with in the wind industry.
Great.
Yeah.
Okay, before I move to the next question, Mr. Tanner or Mr. Prabhakaran, any response? Anything that you heard that you want to respond to?
Yeah, no, it's very interesting to hear some of your challenges in India. Yeah, I think with the point about you have no OpEx budget for additional monitoring solutions. I hear that, but you do have operational budget to fix problems. I'm guessing you're still paying money for repairs, and in that case, if we can prove that the pitch bearing system would save you money, or a condition monitoring system would save you money compared to the operational repairs, then there should be a business case to be made somewhere. So maybe we just need to be we need to show some more data on how much money you can save by monitoring the health of the main bearing, for example, because they're not cheap to replace.
Okay. All right. So I think let's move to the next round. And here what we're going to talk about is what are the kinds of analytics or technologies that they are using, the operators, or what are they expecting? Let me rephrase it. What are the kinds of predictive maintenance or analytics or digital technologies, the new stuff? What is it that they're using, or what is it they're considering using? And what do they think it'll help? How do they think it'll help them? I'm going to begin with Mr. Pachauri this time. Mr. Pachauri?
Right. So predictive analysis, as this is the need of the day, because everybody means all panelists in this platform are very much concerned for the cost, what we have built in for making our IRRs better. So predictive maintenance can be done in two ways. First of all, it can be either done with the sensors or the equipments which are already installed with each WTG, because the WTG OEM have also installed almost hundreds of sensors, which include vibration analyzer, also the gearing vibration analyzer, or any kind of grease sensor, also rotation sensors. Every sensor is being installed by the OEM itself. So those data is already synced with their PLCs, and they are sending continuous data to their SCADA system and to their central monitoring systems also, right? So however they are analyzing it or not analyzing, that is up to them. But yes, the predictive analysis, one kind of that can be done by the data which is available with the wind turbine generator only, right? That can be done. In another way, the predictive analysis can be done through the means of external sensors, which Henry have also highlighted through the help of vibration analyzers, which we are installing externally over the foundations or at other places, through drone inspections. So because blades are the most most prone to damages, because the wind turbine generators which are installed in the on a particular height, then if lightning happens, then out of maybe 100 or maybe 500 turbines, one may have a issue of the blade also. So those can be detected in a very preliminary phase with the help of drone inspection also. So heat-based models are available for detecting those blade profiles. So these are two ways how we can do the predictive analysis.
Okay. Mr. Shah, what is it that you're using in the area of analytics, new technologies, predictive maintenance, etc., that you think has been particularly helpful, and what are the things that you're considering using?
So one of the things, that we have been trying is to have an AI/ML platform. Rather, we have it at the moment, and we have it implemented for all the fleet that we have. And what we are observing is that, yes, we have fortunately not had the pleasure of finding out a failure so far, which is that catastrophic. But what we are seeing is that deviations are being reported. The only practical problem as an owner, if I have to make my decisions based on that information, is that the machine keeps learning. Now, if there is a person who is under you or who is with you, you can evaluate what he has learned and then base your judgment on that. The problem is that what these AI/ML systems are learning within themselves, we hardly have any clue of that, because that depends upon the algorithm. And none of the solution providers so far I have come across who say that the probability of my algorithm being true is 5%, 20%, 60%, 2 years, 200% of what it is. So that, dilemma is always there. So I am also now experimenting another system, which is, so one of the things which is being used by the AI/ML system is looking at the historical data, and with the regression techniques, they are just trying to foresee that, okay, if this was the operating parameter last time, then what was the output vis-a-vis what is there right now? So we are just moving slightly ahead and going with a slightly different SCADA setup, which has actually the capability of handling a couple of millions of data tags. The idea is that AI/ML, in last 2 years of our experience, we were fortunate that we did not actually have any catastrophe so far. But if those algorithms are not transparent to you, you cannot amend them, then it becomes a problem, because I see only what things are shown to me by the software provider. And that's something which, as an engineer, and unfortunately being an automation engineer, I don't like that handicap. So we are working on options. The other issue which happens is that we are unable to integrate other information which is available on my system. For example, if I have condition monitoring, I can't integrate if the AI/ML solution provider does not accept that information. So when I go with these platforms, the limitation of platform becomes my problems. And anything new, that means I have to create a separate platform for that. And as I said before, there is a single operator in the wind farm. And if I push him to see 3 or 4 different systems, I can tell you, being from the thermal background and in instrumentation there for 2 decades, alarm is your response. If you have too many alarms, if you have alarms which are not worth it, people will lose their attention very, very fast. I have for decades. And one of the things which I have always focused on after coming to the O&M belt is again wearing my as an automation and looking at exactly what is the sanctity of alarm, whether this needs an operator's attention. If not, then stop ringing the bell. Otherwise, that guy always keeps thinking na कि ये तो घंटी बजते रहती है. Sorry, Henry, I missed you were there on the call as well. So if the bell keeps ringing all the time, people who are operators, they take it for granted. So we have to have a distinction from that perspective.
Okay. Mr. Samant,
Right.
the same question for you, sir. What are the things that you find very useful in analytics or digital technologies?
I agree with what Neeraj has said, but as a IPPs, most of the IPPs have taken the baby step. They have set up their central monitoring room in each of their offices. Most of them have set up. So what has now started is at least whatever is happening to the turbine, the data from the site is coming to the head office, where they are doing the monitoring of what is happening with respect to the temperature for the turbine or some of the parameters. And what they are monitoring is the power curve of each turbine. That is the minimum thing what they have started. And if the turbines are observed that the turbines are not observing as per the power curves, the alarm is being raised and those alarms are being sent to the OEMs and rectification of the power curve is done. So the baby steps have already started with most of the IPPs. But what another point I feel is that most of the turbines which have been designed in India, most of them say that they will operate up to 40 degrees and all those things. So I really don't know whether these turbines are being designed by most of the great OEMs only to be operated in Europe, or they're also suitable for the Indian conditions. This is a question mark. We need to really find out whether this turbine entire electronics is done for the Indian conditions or it is only for European conditions.
Okay.
We still have to do more detailed analysis of it.
Okay.
Because de-rating of power curve is happening when the temperature goes above 40-45 degrees. And most of the sites where the turbines are going to come in Indian conditions are going to be for the temperature which is going to be more than 45. And we need to find out this. This is going to be a major challenge for all that.
Okay. Mr. Kasotia, what are the things that you're using in this area? AI or analytics or other digital technologies that you're either using or considering using?
In the past, in previous organizations, we have tried to use AI and ML-based solutions. What we realized that there is no sufficient data to actually work that, because for any of the solution, the real thing is a quality data. And the kind of data that IPPs have access to is just for dashboarding, just to view different things, but they are not for really in terms of, coming up with any sort of a logic between the parameters. So one point is that data is missing. Second part is that, the data, the other part of the data, the outcome data, which is basically the O&M log data, which is basically manual. So they are not digitized to really have any kind of a correlation, to come up with any kind of solution, any kind of algorithm. So even if we approach an agency which is doing it, let's say in the West, and the data that we show them what we have, basically other than the dashboarding and visualization, there is nothing that can be done in terms of what we have. So the point is, if this need to be done and this should be done, we need existing data. There is no point to start recording data from today by installing sensor. By the time this quality data, it will be like the ROI will not, justify that. It will take a long data, have this relationship built up, and the algorithm to really start showing some result. We need to have access to existing historical data, and that has to be without any cost. There are a lot of agencies which can make use of this. They have already have the MLN based algorithms to predict what can come out, whether it's a time to failure, whether it's a remaining life, or in terms of, and we are just talking about preventive maintenance, but there is a whole lot that can be done in terms of performance improvement.
Right.
Of the values that we feed into different turbines. And right now we don't have access. As you just said, that we buy these things, we don't have any access whatsoever to change this value. And we see the same value being fed in most of the turbines, and And I can understand from perspective, all they are trying to do is that the machine should perform. They're not pushing their machine.
Right.
There is a lot of load that is still left. There is a lot of things that can be done in terms of extracting the maximum power, but it seldom gets utilized because the value, the offsets that are fed into turbine are not optimum. I believe. I'm wrong. But working with data, like some bit of it, trying to that's what we think. So we're not doing anything because we don't have any good data to actually do it. The only way to do it to install, have new data series coming, and only then ML or AI can come into picture.
Okay. Mr. Shah wants to say something. Mr. Shah?
Yeah, Kapil, I second what you are saying. And that's where, when I was asked about the biggest challenges, one of the biggest challenges that we have is having good quality manpower with our subcontractors, which are the OEMs, because most of them have moved out and taken lead positions around. And, what is left around is not enough. And, I can understand, Kapil, because you are coming from the OEM background. So basically, you have more pain that yaar main ye kar sakta tha aur ye ho nahi raha hai. So that becomes even more difficult when we have a logical sense that this can be achieved in the right way. As you rightly said, there is data available with them, but they are not sharing it. If the data is made available, then life can be more simpler for all of us.
Okay, so let me
themselves are also not doing anything really. If you look at it, it's such a travesty that we have so much of asset here, and you ask anybody, they are not performing to their fullest. We hardly hit P75 numbers, and this is bad for the industry. Really, this is really bad for the industry, bad for the investment, the money that has been put in, and nobody's answerable really.
Yeah, agree.
I think Mr. Pachori wants to say something as well. Mr. Pachori?
So regarding non-availability of the expert resources, so really, Neeraj, you are saying very correct, because from 2012, solar comes into picture. Okay, so the people who become expert in wind turbine, so they don't want to climb the tower now. So they are now preferring the jobs which are at the ground level. Okay, so expert people have migrated from wind to solar, and they are now happily living in solar. So this is the major cause of non-availability of the expert resource.
Okay, let me go to Mr. Prabhakaran. Mr. Prabhakaran, two questions have emerged, certainly two concerns where we would want your input. One is the cost-benefit analysis of this, and two is how do you get OEMs to use? So what should be their strategy vis-a-vis? What is your strategy vis-a-vis OEMs? So two different questions.
Absolutely, thanks a lot. Happy to take both questions. Yeah, so. Well, in all the discussions, what have come out very strongly is that there is a requirement for the technology, but there is a requirement for technology what Onyx is offering, and it's just a question of how do we connect the dots and bring this whole package together and working to help solve the problems that IPPs are facing at this point of time. It's at the end, it's all about risk. Who carries a risk of failure? So if it's an IPP, then it's a decision that IPP needs to make, and we are very happy to work with operators in the market which we have already demonstrated in India that this is a cost-efficient solution which can be brought into the purview of operations in India. And an interesting fact is that our products are all called the main product is called Eco CMS, and the Eco in this Eco CMS is economical CMS solution. So I'm very positive that we can find a sweet spot in terms of the cost when it comes to including the product into the operations. I'm happy to engage with parties who want to explore more here. The second question was was about OEMs, and it's interesting because we are engaging with OEMs, and the OEMs I had personally had discussions with OEMs where they understand the need for bringing predictive analytics into the foray of operations, and also being more transparent and realizing the fact that at the end, it has to be the efficiency, the LCOE that has to come down. So there is buy-in from all spheres of the industry, and I'm hoping that sooner than later we will have solutions where, coming from the OEM side and also where the IPPs have access to the data, and there is transparency in operations, which is inevitable. That is what the market needs at the moment to ensure that we are able to contain the cost of energy for wind.
Okay. Before I go to the next round of questions, I should mention to the delegates that there are many questions that have come, technical questions which have been answered by both Mr. Prabhakaran and by Mr. Tanner. I would certainly urge you to click on those and just see what is there, because I think there are a lot of questions which I think other people would also be interested in knowing the answers to as well. So certainly encourage people to click on Q&A to see what the Q&A that's going on there as well. So next round of question is going to be really about not just about predictive maintenance and analytics, etc., but O&M. And I'm going to this time ask people to just pick the one area that they're focused on right now, the one priority area where they are either striving to improve or the one area that they feel they're going to give a lot of attention to because they haven't been doing well in that area. Related to O&M is what I'm talking about. And this time I'm going to begin with Mr. Shah first.
So I would say that, I have around 12 different wind farms under me, but there is no common problem in all the wind farms. In fact, every wind farm has a different challenge. And one challenge, the only common challenge is ROW, which is there with everyone. But principally in one of the areas where we are working is that we have an issue with the blade. And we are going ahead with a pilot for blade monitoring system. So this is basically based using accelerometer. And we are just trying to work out to have a sense, because this is a new concept. So we are just trying to work that thing out. The other thing which we did was that in one of the cases, we were having a feeling that the static yaw is not properly aligned. So we did a LiDAR campaign in one of the wind farms where the wind direction sensor actually had a very low resolution. So after the analysis, we swapped over the sensor with high resolution sensor, and that helped us to align the yaw movement better to the wind direction than what it was happening earlier. So so these are the kind of initiatives that we are taking, but they are quite segregated and more, site specific, that we are actually working on the solution.
Okay. I'm going to ask the same question now for Mr. Samant. Mr. Samant, the one area that you think people ought to be focusing on or Tata Power is focusing on right now in terms of priority area or an area of attention for O&M?
Yeah, we are looking at this analytical very strongly, the equipment which is behind the turbine. And what we did was we did an exercise with this LiDAR. We have installed on few of the turbines, and we have found that there is a lot of error with this anemometer reading. And by that, we were able to correct. So if we did this testing of this anemometer, we found that the alignment was not proper. So once we did this with one OEM, then the message has gone and he has rectified it on the other turbines also. This was one of the exercises which we did. Similarly, the other exercise, what we are doing is how we can do the all the preventive maintenance has to be done during the low wind period only, and no activity of maintenance should be done during the high wind. And secondly, we are also ensuring that during the high wind, availability of the turbine should be more than 99.5%. These are the factors on which we are working.
Okay. Mr. Kasotia, same question for you, sir. Things that your current focus area, one big focus area for you or one priority area for you.
I mean, again, what Rajiv said, we are also focusing on the low-hanging fruits like LiDARs. And get data right in terms of at least knowing that how much energy we are losing or we are producing, and in terms of power curve matchings and everything. So that is one. And other than that, we were trying to figure out how we can do this newish things. especially the predictive maintenance and the performance initiative, like different angles. So idea is like the way forward, how we can get more and more data and quality data so that we can get into that. Otherwise, we were just like, just waiting and generation is happening and we are just hoping that
Mr. Pachauri, same question for you, sir.
Yes. So it is means really nice answers. Everybody is focusing on something. So I would like to focus both ways, technically and commercially. So technically, we'll be definitely focusing on finishing off all the activities which may be conditional monitoring or whatever, which needs a substantial breakdown in the turbine before the wind season arises, that I can achieve maximum availability during the wind season. So I should be having my turbine available during that period when the wind is high. So second commercial activity means on my focus is that to mitigate the turbines which are almost 10 years old and having older O&M contracts. So now the O&M contracts, if we have started from X, now the O&M prices becomes almost 2x, right? And at this tenure, 2x paying the 2x prices to the OEM is really not at all viable. So now we'll be focusing on reducing this cost so that we can invest more on the things which are being provided by Onyx and other such companies.
Okay, all right. Now, Mr. Prabhakaran, anything that you want to say based on what you've heard in this last round about focus areas and attention areas?
Sorry, Alok, the question wasn't clear. Can you repeat the question?
Anything that you heard one of the panelists say that you may feel that you either want to re-emphasize or you want to respond to, or?
Like I said, we hear from the panelists and also talking to the leaders in the industry. My takeaway is that all the stakeholders, all the participants realize the need for technologies to bring down cost of operations. LCOE, reduction of LCOE, and O&M is a big part of this component of the cost. And measures to optimize this cost is inevitable. And how we do this as an industry as a whole, I mean, it will be unfair from Onyx side to say that, okay, these are technologies, these are the price, and okay, you buy this or don't buy this, and this is your problem. That's not how we want to approach this. We want to approach this from a very collaborative manner. We have the technologies that can be helpful, that can help to bring down cost of operation for IPPs. And we are keen to work together with IPPs in a very flexible manner to identify what is the best model for each IPP and help the IPPs basically to minimize LCOE. So yeah, this is what I want to say.
So my last question to the panelists is going to be, is there anything that you wanted to mention that I should have asked you about that you want to talk about right now? Any particular issue you want to stress, any particular thought that you want to emphasize, something that we didn't cover? And I'm going to begin this time with Mr. Samant.
I think you have covered all the points. Now, only way is, as I said, how we can reduce the O&M costs further.
Right.
So for that, what is the technology or any new product is going to be coming by which we'll be able to know the turbine is operating at 100% efficiency.
So, Mr. Prabhakaran, what they want is a case study from you with a cost-benefit analysis fully.
Absolutely happy to work with the IPPs to develop a cost-benefit ROI study. And this is not always one solution fits all, right? We have to mix and match. Onyx have a wide suite of products which can be feasible for possibly for a smaller, like a sub-megawatt turbine. This additional investment into sensors doesn't help. So we need to work on solutions based on available data, that's SCADA data. And this is also something that Onyx can work with and successfully implemented SCADA-based models for effective predictive analytics wherever the SCADA tags are available.
Let me go to Mr. Kasotia now. Mr. Kasotia, last question for you. Any one thing that you feel we didn't cover that we should have covered, or something you just want to re-emphasize? A closing thought in 60 seconds. Sorry, sir, you're muted, I think.
I mean, we have discussed quite a few things, nothing to add per se.
Okay.
On a lighter note, would like to ask all the panelists, like, what's the way to get our data?
That's the way to get the data, yes. In fact, you would have an idea more than some of the other people will, having been on the other side, right?
I mean, there are plenty of, the companies sitting, analytics companies sitting who can do wonders.
Right.
And can really solve this problem, can really tell us what's going wrong or what is going to go wrong, when and why, and how to improve performance, where is it lacking and everything. And with these set of machines, because we don't have the physical model, it's only the digital version of the model that can be created. And the answer to that is it's the data that is there. So the question really is, how can we get that data?
So maybe we can have something more on simulations and digital twins and all those kinds of things, perhaps.
Yeah, most of us have like wind turbines running for 5-10 years. It's like a gold mine of data that is already sitting there.
Okay, so I think Khushbu, next webinar is data mining for wind O&M. Okay. But before we have to, and data mining here means mining the data from Suzlon and others. Okay. All right. So it's a different data mining, right? Just okay. So let's same question then for let's see. I want to go Mr. Pachauri.
Right. So
closing thoughts, sir.
Right. So almost everything is covered on for layer 1. So now how to do it? We have discussed many things apart. So how to do it? So a question arises that because somebody have highlighted there are one platforms. O&M operator or any other operator may not be feeling very happy in monitoring everything apart from different screens. So integration is a very good thing which we should all think of and definitely implement that how we can optimize or obtain the data from the O&M and then the analytics and then the external sensors like drones and others. All those things should be integrated, and what we are talking as a digital twin that can be our next thought of discussion.
Okay. Mr. Shah, 60 seconds for your closing thoughts.
Yeah. So I think we have covered all the major dimensions. I wouldn't say anything is left out. The only thing which I think is missing as an industry is that you should invite some CFOs on the panel as well. So that, because they are the ones who are the major hindrance for releasing money. Atul would echo what I'm saying. But the sense, is that this is a very complex technology, and the way the whole industry is doing Excel-based projections of 25 years practically do not work in life. Mm-hmm. I think that sense has to get into the, possibly everybody knows it, but everybody wants to push kick the can down the road, and somebody else will have to take it. So I think that is where one thing we need to change. The other thing which I would suggest, if we can, influence somehow, is that somebody had I just missed out, who gave the example of the car industry standards. The IEC standards of the wind turbines, the certifying standards itself, they have to be strengthened to build in machines, because these machines are getting installed in the localities. If any turbine falls down, the injury, because coal power stations and these are completely fenced out, they are not in the public domain. But these wind turbines and this, they are in public domain and quite spread out as assets. I think this kind of sensing mechanism should be mandated in the pre-installation guideline itself. And that will help everybody to be at par. Here, whatever we are saying on the seminar, honestly, we are all competing against each other. Right. So 1 paisa difference plus minus is going to come out only from the technology. If the minimum level itself is set at a safety level, then the industry will benchmark themselves to that level. Okay. And that is how I think we can do things in a better way.
Okay. Yeah. 60-second closing thoughts from Henry and from Sharath. 60 seconds, then it'll allow me to thank people in time. Sharath, 60 seconds, any closing thoughts?
I will let Henry go first. Henry?
Yeah, so thank you very much for this interesting panel discussion. I really enjoyed it. Interesting to hear the issue specific to India, it sounds like you're having some really fundamental problems with getting access to your data, which is a real shame to hear. Hopefully Onyx can help you with that as an independent third-party provider. Yeah, so if there's anything we can do to help you unlock your data and get some value from it, we'll try and do that first.
Okay, Sharath, you have 30 seconds.
Yeah, thanks, Alok. Yeah, nothing much more to add than what we talked about already and the panel discussion. I'll just take this chance to thank all the panelists for this open discussion, and also to the Renewable Watch team for organizing the webinar such effectively.
Yeah.
It's been fantastic talking to the panelists and hearing from them, understanding what are the key issues and also the challenges that we face in the industry in this transition towards digitalization. I take back with me that there's a strong requirement, but there are several blocks which we need to identify and work towards solving. And Onyx is committed to working with the IPPs and all the stakeholders in making this happen.
Thank you. Thank you. It's been a great discussion. And we owe gratitude to Mr. Kasotia, to Mr. Shah, Mr. Samant, and to Mr. Pachauri. Wonderful to have you and hope to see you in person. We're trying to figure out we want to do an in-person conference on wind, probably in February. And we hope to see you in person there, or maybe even sooner than that. Again, thank you very, very much. We promised you we'll be done at 1 o'clock, especially Mr. Kasotia. We are done at 1 o'clock. So you're able to get to your next meeting. Thank you again. Thank you. And I should mention that our peak attendance today was 120, and we were pretty much above 105 for most of the discussion. Okay. So
Thanks.
very
Okay.
Thank you. Thank you very much, everyone.
Thank you.